We'll now discuss another way to find the limits of sequences called the Squeeze Theorem. First, we're going to suppose we have two sequences, a sub n and b sub n, and both of their limits are the same value, L. We're then going to further assume that we have this other sequence called c sub n that's trapped in between a and b. And then the limit of that middle sequence, that c sub n, has to be equal to L as well. So essentially, we're squeezing this sequence in between two other sequences. Let's look at a few examples. My first sequence, sine of 4n plus 2 divided by 1 minus the square root of n. Well, one of the things that we know about sine is that it's always trapped between -1 and 1. And sine will always be between these two values. So then I'm going to divide all the way through by 1 minus the square root of n. The limit of the left-hand side is going to tend towards 0. And the limit of the right-hand side is also going to tend towards 0. So the limit of the middle is going to be 0. Another example, arctan of n over n squared minus 2. Arctan is always going to be between pi over 2 and negative pi over 2. So once again, I'm going to trap it between two values, and then I'll divide all the way through by n squared minus 2 so that I have this sequence in the center. As n tends towards infinity, the left is going to be towards 0 and the right's going to be towards 0. So the limit of the center is once again 0. This one, 3 to the nth power over cosine n, 3 to the n plus 4. Just like sine, cosine is going to be trapped between 1 and -1. So on the top, that cosine is going to turn into a 1 and -1. So on the left, I'm left with -3n. On the right, positive 3 to the nth. And then I'll divide by 3 to the n plus 4. I'm going to go ahead and use some properties of exponents that makes this -1 over 3 to the 4th less than or equal to 3n cosine n over 3n plus 4, which is less than or equal to 1 over 3 to the 4th. On the left, I'm left with -1 over 81, and on the right, positive 1 over 81. So from the Squeeze theorem, I actually can't conclude anything on this particular one. The limit could be somewhere between -81 and positive 1 over 81, or it could just oscillate between the two of these numbers. So here we can't definitively say what the limit is. Let's look at one more example. Here I have n cosine n over the square root of n. Cosine is going to be trapped between -1 and positive 1. So on the left, I have -n over the square root of n, and on the right-hand side, positive n over the square root of n. Reducing this, on the left, I'm going to be left with negative square root of n, less than or equal to n cosine n, less than or equal to positive square root of n. As n tends towards infinity, I'm now trapping these between infinity and negative infinity. So once again, I cannot say anything about this. I'm now giving an entire huge range. So the Squeeze theorem is not perfect, and it doesn't always work.